Hi, I'm John Myers. I'm the Senior Virtual Design and Construction Manager for Gilbane Building Company. Real quick, how many AEC, architecture, engineering, construction folks do we have in the room? That is awesome. I am so happy to see that. Okay, so for those of you who aren't in AEC, we're going to go through some basics in the beginning to understand kind of bidding and procurement. How many like other engineering, so like aerospace, mechanical, anybody else who wouldn't fall under the AEC? A few more? Okay, so some of this might be pertinent to you from a bidding and procurement standpoint. We're going to talk about schedules, we're going to talk about budgets, and we're going to talk about how do you drive efficiency as construction is trying to join aerospace and becoming an efficient industry where it's not been for the past ever. So let's get going. So in the past, back prior to 1980, 1990, construction in the US was very much design, bid, build. You had an architect and an engineer, you put plans on the table, and then a contractor would bid those plans and specs, and then they would go build the building, right? Buildings start becoming complicated, 90s, aughts, post-aughts, and we get to positions where owners want buildings faster, they want them smarter, and they want them cheaper. And so we have to, as contractors, as that's what we do, we're a construction company, as contractors, we have to give owners what they want, otherwise we're going to be out of the market, we won't be competitive. So we have to be able to put schedules together and put prices together that are competitive, but also that means that we can't afford to do things like build things twice. Like back before 07, 08, I don't know how many of you know this, but construction schedules had something called float in them, and maybe other procurement schedules have this too, where we basically built things in to build it twice because we knew we weren't going to be able to build it right the first time. And we've really had to evolve in a post-recession environment so that we know we can build it once to the schedule that we have without overtime. And we're going to talk about overtime as we go forward too, because it's a big piece of how construction works. And what we're trying to do as construction managers is build it once correctly the first time. Okay, so again, design, bid, build. There's really no opportunity for collaboration. The builder's not at the table. Plans and specs go on the table. We put a lump sum bid in. Low bid wins. As buildings get more complicated and get more complex and get harder to put together, if plans and specs aren't exactly perfect, costs for the owner goes insane. And what the last guy from Nat Grid said was so important, is that putting buildings together, if you have enough time, it works, you can do it perfectly, but then the hard part is communication, but it becomes the most important thing. We don't want to be fighting each other over the course of a 3 or 4 or 5 year project because it becomes brutal and people lose their hair and it becomes owners lose money and projects go over schedule. So our job as construction managers is to make sure that communication stays on par, right? 2004 to 2008, construction and architecture decided it wanted to join aerospace and other engineering and start to build with 3D models instead of doing things generated from drawings. So we use programs like AutoCAD, we use programs like Revit, and what we try to do is build the buildings in the model first, and then go through, do constructability reviews, simulate schedules, generate prefabrication solutions to drive schedules forward. And the thought process is, okay, we have a traditional delivery, even in the 2004 to 2008 era, where you've got 3D models and we're building them and we're producing drawings for them, but we're not really simulating with them, right? We're not really walking through the buildings and looking at them ahead of time. Buildings are really expensive. Like they are an incredible investment. The average school in Massachusetts now costs around $100 million. That's a serious chunk of change, and it's getting really important for owners who don't want to build things twice to be able to simulate their entire building life cycle before they build it and before they spend that money. So the reason why we start to drop in augmented reality, mixed reality, and virtual reality is to get to that level of simulation, right? We need to give the owner the surety that what they're buying is what they want. We need to give the architect the surety that what they drew is what they want, and we need to give our subcontractors, the duct guy, the pipe guy, the electrician, the steel guy, the surety that they're going to be able to come in, put their work in place in the order that we promised so that they aren't going to lose money because our margins are so thin. So the question then really becomes, and this is really hard, I'm an architect by training, there's probably a few architects in the audience, Are contract drawings good enough to build to these days? And most construction managers and most builders will say, no, man, we have to go through another set of iterations. And if we have to go through another set of iterations before we can build, the argument is then why not start that iteration while we're in design, right? And this is like what success looks like, right? When you can scan the building afterwards and your point cloud is your model and you didn't have to change any valves, you didn't have to relocate a chiller, you didn't have to do anything crazy in putting it together. That means you found the optimal build solution when you did pre-design, pre-construction, and shop drawings. Like, that's golden. That's what we want. We need this to build buildings. We have to have a 3D building model before we build them. There's no more room, there's no more float in the schedules to build it twice. We can only afford to build it once. The construction managers can only afford to build it once, the subcontractors can only afford to build it once, and the owner definitely doesn't have any more money because they're bonded through their insurance, through their lender. So it's getting to the point now where we are striving for that last 10%. And it goes back to what's the design intent versus how do you put it together. Design intent and means and methods deviated in the 80s when the insurance company said, we don't want architects and engineers weighing in on how buildings get put together. And it threw the industry in a 20-year shock of how do we reconcile means and methods and intent. And this is a great example. We have a public detail in Massachusetts that took 4 months of extra redesign just so we could put it together. And we ultimately had to build a 3D fabrication model for curtain wall, which you'll see here in a minute, so that we could prove and simulate that it would go together. This is for a school in Massachusetts. This isn't a performing arts center. This isn't a pharmaceutical manufacturing facility. This is a school. So it's getting to the point where if construction and AEC doesn't join aerospace and mechanical engineering in how they put their assemblies together, we are going to fall behind. The guy from NatGrid had a great strategic presentation. We're going to talk today is a little bit about tactics. So like when we actually have to put a building together, what types of models are we throwing into our mixed reality and augmented reality so that we can tell our superintendents and tell our trade contractors how they're going to put a building together so they don't have to build it twice. Right? So I'm sure you guys have either seen HoloLens or heard of HoloLens. We got it. We were an early exhibitor of it. We are not using it in a traditional augmented reality sense. We are putting it on our superintendents, like in the image you see, so that they can understand at the assembly level how individual assemblies fit together. Because that's all buildings are. Just like a car is a car has a door, and the door is made up of subcomponents. Buildings are the exact same way, right? You have a curtain wall that's made up of steel and glass and brick and waterproofing. And all those layers have to go together in a certain order. That's the means and methods of the construction. We need entire project teams, all the trade contractors who have to contribute to that, to help participate building this item ahead of time so that when they put it together in the field, it's exactly in the order that you want it to be so you don't have to take things apart in order to put something else on that you forgot. Part of the awesome thing also about the HoloLens is we can blow it up, we can shrink it down, and I can actually have my superintendents walk around the object in the middle of the floor, peek into it, hover over, do on-click, see what element, what the data is behind it, how thick the glass layer is, what type of waterproofing, what type of insulation, how thick the brick layer is. All those types of embedded information, to us, that's what the augmented reality was meant for. Overlay information on top of information that's all buried in a database somewhere. And then finally being able to blow it up, huge scale, full scale, walk inside it, look up, find collisions, find conflicts, finds areas of constructability. Everything you catch ahead of time is worth $5,000. And that may not seem like a ton of money on the massive scale, but if you go through and you catch 30 things, and each one's worth $5,000 of overtime that you won't spend near the end of the job, and consequential damages that you will avoid by meeting the schedule on time, those hugely add up, especially in an industry like construction where the margins are so tiny, again. So what we're trying to identify is new ways to prototype our assemblies. And we'll talk a little bit about VR in a minute, but on the assembly standpoint, this is another job. When you talk about value and you're putting pipe in the field that costs $1,000 a linear foot, I can't cut the valve out if the valve goes in wrong. $1,000 a linear foot. We have 9 kilometers of this pipe in the building. Do the math, it is insane. We cannot afford to screw it up. Everything has to go in right the first time. The owner will make a significant amount of money for every day this building is completed ahead of time. The financial incentives are massive to do things right the first time, which is why our owner is really great, and they're basically saying anything you can do to innovate and push and gain us a single day of schedule is huge, right? So let's pause for a minute. Builders, contractors, myself included, historically don't really like to contribute to a design database or a back-end database. They want to show up, they want to be told what to do, they want to put their work in place, and they want to go home. They want to go home safely. It becomes a total shift in the construction industry for me to say, you must model this way, you must model with this software, you can no longer do things the way you've always done them. We need this from you, we need this from you by this date. It has to be to this standard. And in the aerospace and the mechanical engineering industry, those aren't really that hard to do, right? There's a SolidWorks standard, there's a CATIA standard, and maybe there's a few others, but most of the stuff you're gonna get is one standard or another. In the building industry, there's like 30 different types of AutoCAD plugins, and each subcontractor picks the one they want based on how they felt that month when they bought it. So we basically said, no more, everybody's gotta use the same software, and it has been really, really tough, right? But when you do it, come on. When you do it, you end up with a single model that uses the same database back end. So when you want to simulate something, you can pull from the same database. You can pull, everything gives you the same Excel output in the same format for 20 different subcontractors who all have a different scope of work. When you're putting together a $200 or $300 or $400 million building, you don't have the time to sort through everybody's individual databases. You need them to conform. So that's the big kind of secret sauce of how do we get construction and architecture to have that advantage, to contribute to the same database. We all got to be aligned. And to our subcontractors' credit, over the past 2 or 3 years, they have responded in a way that I was not anticipating. Everybody's gone out. They've all said, yep, we'll have at least one person in the office who conform to the standard. And when we bid a Gilbane job, we will do it that way. And it has turned, like, the value for us is we've gone to shop drawings, fabrication drawings. We have a building for a central utility plant that we did 3 years ago, and one we've just done in the last 6 months. And we shaved 3 months off shop drawings by doing it single database way. Also, it lets you do things like load up things into VR and AR software and multidisciplinary overlay the model and assembly so that our supers can put multidisciplinary scope in place correctly the first time. And then, you know, the proof's in the pudding. Does the point cloud at the end of the job, when you scan it and give as-builts, agree with the design at the beginning? If so, you did your job. If not, you didn't. And that's what we judge, the standard we judge ourselves by. Did the scope go in as we promised we would? Quick VR conversation about it. Augmented reality is phenomenal in construction for us at the assembly level. It struggles with immersive spaces, right? You have a limited field of view. For the VR piece of it, it's kind of a different end user who wants to look at it. We get to work in lab buildings and manufacturing buildings with scientists, with some of the best universities in Boston, with some of those brilliant people I've ever met, and none of them can read a floor plan because architecture floor plans are created in such a way to be convoluted in a lot of cases. And what we need to do, if you're going to spend $200, $300, $400 million on a building, you need to know what you're going to buy. So the cool thing about it, the VR piece of it, is that we're able to walk our owners through their building spaces while things are still in their shop drawing phase. And because we're all in the same database, you have a multidisciplinary overlay. So we can look at the pipe guy, the electrician, the duct guy, the architecture, the structure, all in the same run through, all at 60 frames a second. Run through it. When they don't like something, they point at it with the Vive controller, with the laser, say, I don't like this. We take notes, we change it. 5 minutes later, we hit start again and we go through. That's the ability when you've got a team of 20 that would used to take 2, 3, 4 weeks to get resolved. You gotta all be in the same database though, and you gotta have the same origin point, and you gotta have all your subs on board with contributing to that database process. Quick how, we got 4 minutes left, I'll slow down a wee bit. Including questions, all right, so we'll stay on track. The coolest thing I think is, I have an architecture background, so we have the 3D modeling background and the rendering background, but the cool thing, and also the kind of other edge, the double-edged sword, is that we now have to create video games every time we want to do a simulation, which is like totally interesting, but also very difficult level of how much do you do and how much is too much, and your super may only need 20 seconds or he may need 10 minutes with it to understand it. So the building of the video game and the building of the user interface and how on every single assembly we have to show something different or animate it differently does become a challenge. But it's really helped my team learn how people learn, and we get better every time we do it. So we make people, like my team map out like what does each superintendent need, what does the detail need to show, how much animation do we have to show on it, how much information overlay do we have to show on it. That way, I mean, more like the N-Grid guy mentioned, it's really about, there's a certain value. We don't want to brute force the whole thing. We just wanted to get very targeted values and very specific deliverables out of the effort we put in. And then, so we use for the mixed reality, augmented reality, we use Unity, which is great. It was one of the first ones we learned. And then for VR, we use Unreal, and we use some proprietary Revit plugins. And you know, it doesn't work instantaneously, but it's pretty easy. I mean, none of us have computer science backgrounds, and we've picked it up decent. So it's something that's very reasonable to do if you're a construction or architecture company. And then, you know, finally, we get to work in some of the coolest spaces in Boston. We get to build some of the coolest spaces in Boston. And our owners love this stuff. So it's making an owner and seeing it click with an owner is like 90% of why we do it. The other 10% is making our supers get it and knowing that they're going to put the scope in place the first time. It's something where the construction industry just needs to get there. It needs to get there quickly, too. So, questions? Shoot.
So what software did you decide to have everybody use?
So we have all of our subcontractors in Revit for all buildings $30 million or larger. So in the past, they've all used whatever CAD plus whatever plugin they've wanted. Now they all have to use Revit. They're allowed to use plugins for Revit, but all the geometry natively has to be in Revit, which is really awesome when they added the Kobe plugin, because now instead of redoing an entire Revit model for a turnover as well, we make them fill out their Kobe spreadsheet and hit the push button, associate, and we're done. So that's another reason why we did it. Instead of doing it again for as-builts and for turnover, it's done when we're done with shop drawings. So it's, shoot.
This is Martin Leica from Leidos. I have a question for your immersion applications.
Yep.
When you have a building that's like 100, 200, 300 feet long, do you run into issues with your tracking, like with your lighthouse or whatever technology you use? And also in the rendering performance, do you use distributed rendering, or is it all one central spot?
So we do a couple different things, because the scale things are really hard. Anything with the HoloLens is at the assembly level. So the largest thing we've done is one mechanical room, and that almost becomes unwieldy from the triangle standpoint alone. When it comes to virtual reality, the proprietary plugin we use when everybody's in Revit does a really great job of only rendering what it sees. So that piece of it is really great. We also don't put a big room up all the time. If we're going to do an immersive, like, great, use the controller and pick up this skid or this, you know, this conduit or whatever, yeah, then that becomes an issue with walking, and we'll use a combination of controller plus walk to get where we want to go. But for the most part, we keep them within a box X distance by Y distance, because, you know, we do a lot of this in job trailers as well, and job trailers aren't exactly the most expansive spaces, so we have to do that. But what we find is the owners really love the laser teleport. I don't know if you're familiar with the Vive laser, or even the Rift one has it too, where you pull the trigger and you go 200 feet away, which is, that helps people, because really what you want is, as you approach a piece of equipment, you know, you get close up to it and then you reach out with your hands and you touch it. Can I turn this valve? Can I get underneath it? You know, do I have enough egress space to walk and turn and manipulate? So we're really lucky in that we don't have those problems, because I can even go back, and I'm out of time, but I can go back. We were DK1 and DK2 early adopters as well, and we kind of figured some of that out when we did DK1 and DK2. Awesome. Thank you.